Hi everyone, we're back again for another edition of Next Level Wholeness, and today we're gonna have some fun. And to start off with, I decided to play with some magnetic eyelashes, so that's why there's so much of them today. But it was kind of fun. Just make sure that you have enough of the magnetic eyeliner to attach your lashes to, and they were so easy to do. Anyway, today we are going to talk about methylation. Now, methylation is such an interesting subject, and I'm so excited to be sharing this with you. However, I try to keep my videos kind of short and sweet and under 10 minutes, but today's is going to be a little bit longer. So I really want you to stay with me because the information is so worth it. So let's get started. What is methylation and why should I care about it? And the reason I decided to do this subject today was because of the genetic testing, the 3x4 genetic testing that we do in our office. A lot of people are showing up with some gene variations in their methylation pathways. So methylation is such a hot topic. You've probably heard of methylation and how important it is for your health, but you may not know how powerful it really is. Even though it's amazingly simple biochemical action that takes place in every cell of your body. Put simply, methylation is the addition of a methyl group to a molecule. Demethylation is the opposite, the removal of a methyl group from a molecule. A methyl group is made up of 1 carbon and 3 hydrogens, CH3. That's it. Methylation is a basic cellular switch, a switch that keeps turning off and on billions of times a day and allows the biochemical gears of your body to turn smoothly. You might think of methylation as a switch that changes everything. You may also have noticed it referenced in things like genetics, autism, insomnia, neural tube defects, and even in heart disease and cancer. Methylation is a very important process in every cell in the body. Methylation is the methyl group, CH3, as we discussed a little earlier, attaching itself to an enzyme in the body, and then this enzyme performs a specific action. This controlled transfer of methyl groups onto proteins, amino acids, enzymes, and DNA regulates things like healing, genetic expression, liver detoxification, and immune function. Methylation helps regulate your response to stress, your brain chemistry, immune function, the ability to keep viruses in check, including latent viruses we harbor but suppress, the activity and expression of your genes, and your capacity to detoxify. In the liver, methylating a toxin will transform it to a safer form that can be more easily processed and excreted. Methylation also regulates the responses of genes to environmental factors and diet. As you age, your ability to methylate can change. Methylation is the switch the body uses to help direct a baby's development in the womb so that the organs and tissues form properly and at the right time. Methylation is so important that its actions in the womb or early life can lead to permanent, lifelong changes. Changes that can even be passed down to the next generation. And this was conclusively shown in a famous study of mice, where simply feeding mama mice vitamins important for methylation during pregnancy turned their fat, yellow-furred offspring into lean mice with brown fur. The vitamins B12, folate, choline, and betaine switch off an important gene by adding methyl groups to it. These methylation changes can be inherited by subsequent generations. And that's not all. Methylation defects due to deficiencies of the B vitamin folate in papa mice decreased sperm counts and increased mortality in offspring. And in humans, the impact of diet in mothers is equally potent. A study of babies who were conceived in the rainy or dry season in rural Gambia in Africa found methylation patterns were altered accordingly. The rainy season was linked to better nutrition with higher levels of methyl donors called SAMe, which is S-adenosine L-methionine, and higher concentrations of methyl donors like folate, betaine, and methionine. Rainy season moms also consumed higher levels of vitamin that assists in methylation, such as B2 and B6. The rainy season babies were born with naturally higher methylation activity that likely will influence many aspects of their health lifelong. They had an advantage over the children conceived in the dry season. That's pretty profound. Methylation is the fundamental language of life. Through methylation, your internal and external environment can talk to each other. When methylation is slowed, hypomethylation, we can have trouble suppressing viruses, processing toxins in the liver, controlling inflammation and oxidation, and generating sufficient neurotransmitters in the brain. It's important then that we have optimal methylation. The body is a very complex machine with various gears and switches that all need to be functioning properly to operate optimally. Think of methylation and the opposite action, demethylation, as the mechanism that allows the gears to turn and turns biological switches on and off for a host of systems in the body. When optimal methylation occurs, it has a significant positive impact on many biochemical reactions in the body that regulates the activity of the cardiovascular, neurological, reproductive, and detoxification systems, including those related to DNA production, neurotransmitter production, detoxification, histamine metabolism, estrogen metabolism, eye health, fat metabolism, cellular energy, and liver health. The methyl group is provided to the body through the universal methyl donor known as SAMe, which we mentioned earlier. SAMe readily gives away a methyl group to other substances in the body, which enables the cardiovascular, neurological, reproductive, and detox systems to form their functions. Unfortunately, the system that produces SAMe is reliant on one switch being turned on by a critical B vitamin, 5-MTHF, which stands for 5-methyltetrahydrofolate, also known as active folate or methylfolate. Excuse me. If enough 5-MTHF is present, the methylation cycle will work efficiently. Folic acid from the diet or supplementally must be converted to the active form 5-MTHF before it can be used in the body in the methylation cycle. And unfortunately, approximately 60% of people in the US have a genetic mutation that makes it challenging for their bodies to create enough 5-MTHF. When the methylation cycle is turned off and isn't creating enough SAMe, there's a number of important molecules. Then cannot be efficiently produced, including glutathione, CoQ10, melatonin, serotonin, nitric oxide, norepinephrine, epinephrine, L-carnitine, cysteine, and taurine. There's a wonderful genetic test, 3x4, that to help you find out if you have problems in your methylation cycle. You've read a lot about the mother of all antioxidants, glutathione. It is our most important endogenous antioxidant, and the glutathione supersystem, which includes enzymes and cofactors, is critical for binding to and neutralizing innumerable toxins generated in everyday life. But you may not know that every moment of every day, your body comes to a fork in a metabolic road and has to decide, should I activate methylation or should I make more glutathione? Which one is more important right now, right in this moment? Here's how it works. Methylation and glutathione are tightly linked and move in lockstep. There's a critical fork in the road where cells get to make an important decision again and again and again. That is, should I make more glutathione or should I support more methylation? optimal balance between these two choices is the bedrock of good health. Though there are many enzymes and cofactors that contribute to both methylation and the synthesis of glutathione, a short and simple version of this decision goes like this. Let's say we need to methylate a gene or perhaps a latent virus to quiet it down. A methyl donor called methionine can give up its methyl group and accomplish this for us. But then we are left with the metabolite of methionine, homocysteine. Some homocysteine is okay, but too much has been linked to cardiovascular disease, and now the body has to decide. Should homocysteine be methylated or be transformed back into methionine, or should homocysteine be converted into cysteine, which is the building block for glutathione? Glutathione or methylation, again and again. This fundamental decision is made, like I said, again and again by the body. If we make too little glutathione, we end up with oxidative stress. But if we don't methylate enough, many genes and viruses will not be regulated, will not be properly regulated. A balance of both is key to optimal health. And now, onto genes. Genes are encoded by little proteins in what is called DNA. These genes indicate things like biological traits, your eye color, hair, skin tone, skin color, etc. But they can also influence how our body responds to their environment. Our genes provide the code for how our bodies will function, and therefore it's not surprising that significant attention is being paid to the human genome. Lifestyle factors can influence whether our genes are activated or deactivated, meaning we may have a predisposition based on our genes, but it does not determine our destiny. Methylation is one of the ways that the body makes sure the right genes are turned on and the ones we don't want expressed are turned off. One of the most well-studied genes in terms of health is methyl tetrahydrofolate reductase, MTHFR. MTHFR is an enzyme that is responsible for the process of methylation in every cell, specifically one that converts folate into its active form, the 5-methyl tetrahydrofolate, that can be used to make S-adenosylmethionine, SAMe, which is an important compound used in most methylation reactions. It is very common, as mentioned before, to have a genetic variant that causes the key enzyme to function at a slower rate, which can negatively affect many other processes related to methylation. While lifestyle factors can significantly influence the activation of genes, certain genetic mutations can influence how certain people respond differently to the same diet or lifestyle changes compared to someone else. The two most noteworthy genetic variants for MTHFR are CT667T and A1298. We will not go into these variations too deeply here today because these will be discussed in greater detail if you choose to get our 3x4 genetic test, which I may add is a genetic test that does not bank your DNA or disclose it to anyone other than you and your practitioner. Another important aspect of MTHFR is homocysteine balance. Gene variants or mutations can lead to high homocysteine as well as other issues such as migraines or miscarriage. I also want to mention that if you choose to do the 3x4 genetic profile, that we can send you like a sample report so that you kind of know what you're getting into. So feel free to reach out to us via email or text, or just contact naturalhealthhaven.net is our website, and we can forward more information for you. Okay, when the MTHFR gene is functioning optimally, it helps to keep homocysteine within normal levels. These levels are often tested if someone has heart disease, as higher levels of homocysteine correlates to worse outcomes. Higher levels of homocysteine or low levels of folate and B12 are other flags that potentially impaired methylation. The B vitamins that matter for methylation. Many B vitamins and methyl donors contribute to both methylation and detoxification. But at the center of the wheel spokes are two B vitamins. These are the active methylated form of vitamin B12, methyl B12, and the active methylated form of folate, methylfolate. If we don't make enough of these active forms, we will not be able to smoothly and fluidly shift between methylation and glutathione production. Vitamin B12 is found in abundance in animal-based foods like meats and eggs, and is extracted from our food and chaperoned into cells where it is processed into the two active forms. For those on vegan diets or with gene variations that render this process less optimal, supplementation with active forms can help. Vitamin D12 is constantly recycled. It donates a methyl group to homocysteine, which then turns homocysteine back into methionine. Once B12 has lost its methyl group, it needs to acquire a new one. Methylfolate is the sole molecule that can donate a methyl group to B12. Once it does that, the rest of folate can further support many other actions and reactions in the body that needs folate. Methyl B12 helps your body synthesize new DNA and RNA, as well as new red blood cells, and is important for optimal neurological function, mood and memory, and bone and heart health. Vitamin B2 is especially significant for those with less than optimal MTHFR variants. Since MTHFR is a vitamin B2 containing enzyme and is thus dependent on adequate B2 levels for full activity, B2 deficiency can also lead to lower levels of reduced glutathione, GSH. Supplementing with generous amounts of B2 may offer support to MTHFR. Also, for those with variants in this gene, betaine and trimethylglycine, TMG, offers a safe source of methyl donors that support methylation without driving it too fast or too hard. Both vitamin B6 and activated folate are also important for optimal methylation, especially in those with MTHFR issues. Vitamin B6 helps the body convert homocysteine to cysteine. Abnormalities in methylation have been found in a whole host of conditions, from Alzheimer's disease to cardiovascular disease to autoimmune illnesses such as rheumatoid arthritis and lupus. Poor methylation can also affect neurotransmitters, leading to mood changes and depression. Both folate and B12 deficiencies can lead to depression and dementia, likely through a defect in the methylation process. In fact, methyl donor SAMe has known antidepressant properties. Proper DNA methylation has been shown to help suppress cancer and tumor growth. There's an intriguing connection between histamine, the neurotransmitter implicated in allergies and mast cell disorders, and methylation. Histamine is important for dilating blood vessels, sneezing, nasal congestion, sexual function, and erection, and even the secretion of hydrochloric acid in the stomach. Histamine is implicated in allergic responses, and it is released by mast cells in response to allergens, leading to familiar symptoms of sneezing, wheezing, itchy eyes, rashes, and more. Proper release of levels of histamine require adequate methylation. There are variations among individuals in the genes that regulate methylation of histamine. In addition, new research suggests that folate metabolism may also be linked to allergic disorders, adding another possible connection to methylation. To help balance methylation, most deficiencies are treated by using supplemental nutrients to help improve enzyme activity. One drawback of sitting outside doing this is like little bugs everywhere. Most notable nutrients are folate, 5-MTHF, B12 and betaine. It is common for people with methylation challenges to be recommended methylated folate and methylcobalamin, B12. Because methylated folate is a normal product of the MTHFR enzyme, it works better as it bypasses the enzyme blockage. It's important to maintain the right balance, not only through supplementing, but also consuming food-based nutrients, methylation adaptogens, healthy eating patterns, exercise, good sleep, and minimizing stress. In addition to a healthy whole food, non-processed food diet, make sure you're eating a lot of the following foods: asparagus, avocado, broccoli, Brussels sprouts, green leafy vegetables, legumes like peas, beans, and lentils, rice. Obviously, avoid your known food sensitivities. Lifestyle changes include engaging in regular physical exercise, avoiding excessive alcohol consumption, don't smoke, avoid excessive caffeine consumption unless you're a rapid metabolizer, which the 3x4 genetic test will show too. There are 7 specific nutrients that can help methylation cycles achieve optimal performance, even if the individual has genetic variants that slow it down. 1. 5-MTHF, the methylated folate. 2. Methylcobalamin, your active B12. 3. Pyridoxal 5-phosphate, your active B6. 4. Riboflavin 5-phosphate, your active B2. Magnesium, betaine, also known as trimethylglycine, and vitamin D3. Proper methylation influences so many systems in our bodies that often get overlooked, which can severely impact how well your body functions. Here's an interesting tidbit on methylation and maintaining youthful vitality. Everyone seeks that proverbial fountain of youth, not only to live a long life, but to do so with energy and youthful vitality. Changes in DNA methylation occur during aging and may contribute to the aging process. One molecule that has been of tremendous interest lately is NAD+. Now this is going to be an interesting one for me to pronounce. Nicotinamide adenine dinucleotide. Oh, mouthful. It's been called a true anti-aging molecule, naturally present in every cell and critical for DNA repair, cellular biogenetics, genomic signaling, and cell survival. As we age, we experience a steady decrease in NAD+ levels in our body. Higher levels of NAD+ have been shown to increase the body's resilience to the diseases of aging, possibly extending healthy human lifespan. As our body synthesizes NAD, methylation activity increases and methyl donors are consumed at a higher rate. In fact, NAD+ and methylation are closely linked. For optimal health, the two cycles must be balanced. I guess by now you've realized that everything that we talk about is always about balance, balance, balance. If you're interested in adding NAD+ to your nutritional support regime, I highly recommend Vitamin Drip Minnesota. Dr. Chris Frickman is amazing, and they do an NAD+ vitamin intravenous IV drip. You can add glutathione to any of your IVs or get a glutathione push, as well as many other health nutrients and immune support IV drips. I really hope that this discussion has given you a better idea of methylation and how important it is and why it's so important for you to know if you have challenges in this area, to improve your long-term health and well-being, to improve detoxification and just like natural health. It's important to mention that this information was obtained from various sources, including a wonderful blog by Newbridge Wellness, an article by Thorne, and Quicksilver Scientific. As always, thank you so much for listening. Be kind, be gentle, and have a next level healthy day. Bye.